Webinar is going to be get recorded and will be posted on the YouTube channel. So if you find this webinar useful and if any of your friend has missed this webinar, you can share the link and send and they can go to the Solar Labs YouTube channel and can view the masterclass there only. So let me present my screen. Okay, so it is here. So let me give a brief introduction of me and myself before starting the masterclass, and then we will reach to the topic. So my name is Ayush Akbar. I am a mechanical engineer by education, and as of now, I am working as an account executive at the Solar Labs. The aim of the Solar Lab is to increase the pace of solar rooftop adoption, not only in India but across the world. We are an IIT Mandi startup. We started in the year of 2017, and after a 2-year extensive research with the industry, their collaboration, after knowing the supply and demand gap, we come with the product the Solar Labs for designing and aiding purposes. Reaching to the next slide. These are the topics that we are going to discuss today. The first topic is what is solar O&M. Second, why we need solar O&M. The third one are the different approaches that usually are taken by the experts for doing the operation and maintenance. And the fourth topic is the automating the O&M, as the trend is going as of now that everything is automating. So what is solar O&M? Let's understand it. So there is a widespread myth in the solar industry that as long as the sun is shining, the plant will work fine. However, this couldn't be further from the truth. A solar plant is built to last for more than 30 to 25 years. But the associated electrical balance of systems, the BOS components, are not. The average solar inverter needs to be replaced every 5 to 10 years, while a lithium battery ion, that is a very common component in an off-grid connection, has an average lifespan of only 2 to 3 years, though the lifespan is increasing, but as of now it's 2 to 3 years. And that's why, as a PV plant owner, as a customer, we have to ensure that the plant operates under optimal conditions to meet the energy needs as well as to make high returns on one investment. To give a very brief introduction about what is solar O&M, it is a set of technical activities that allow a solar plant to perform at its best, maximize the system's power production, and enable it to function smoothly. This covers an array of tasks from routine cleaning to addressing technical issues as they arise and so forth and so on. Solar O&M is a part of a larger set of solar asset management, which is a holistic approach rather than a technical one. Solar asset management encompasses technical, commercial, and financial aspects of a PV plant. The transaction of assets between constructors and operators is known as handover takeover. The short form of handover and takeover is HOTO, and we will be referring in the future this photo. The maintenance includes both scheduled and unscheduled events. So, scheduled events are mandatory within a time period. So, these are like regular operations, regular maintenance that needs to be done, which is generally outlined by the manufacturer. Whereas unscheduled events requires emergency response, and here comes the role of the O&M service providers. They need to be on their toes and be there whenever an emergency strikes for unforeseen failures in an effort to reduce the downtime and the production. The Green Tech Media has divided 5 major goals of solar O&M. The first one is optimization of solar production to increase asset revenue. Optimized solar production can reduce payback period, increase the savings, as well as also reduce the degradation, LID, and many other things. The second is the reduction of risk for asset owners. If a plant is not managed properly, is not maintained properly, then it can lead to even fire, the short circuit, or any other thing. So, in that sense, a well maintained plant reduces the risk for asset owners. The third goal is for the protection of asset value and the longevity, as we have already discussed. The fourth is the compliance with applicable regulations. So it becomes very important if the plant is of utility scale, as we are seeing many plants are getting sprung up all over India, from Gujarat to Tamil Nadu to Hyderabad to any place you guess, UP. And the fifth and the most important goal is the transparency of production performance issues, risk, and OMN activities. So, as service providers, we want that there's a transparency between the service providers, between a generator that we have predicted and the owner who is using the product. Now, reaching to the next slide, I want to show you this video. Here you can see that as the woman is going to put the strip, raise the strip, and making it to the center of the panel, the power of the pump is reducing, and so you can see that the water is not raised through properly. Give it a one or two C's and see whether you are able to understand it. As soon as the woman is putting the strip upwards, it's blocking the sunlight, and so the power production is getting reduced. And so for a small pump, you can see that the water that should be raised is not raising. I think so this video is enough to show that how important it is for operation and maintenance, for the operation of maintenance. If a plant is lying with dust, the dust is there, pollens, train pollens, trees pollen, flower pollens, etc. is residing on the plant, on the panel, then it can reduce the production and can hamper the payback period, the financials, and many other things for the asset owners. Reaching to the next slide, what do you say? What do you say a solar plant is a successful plant? A plant is successful, especially solar plant is successful, not simply because it is able to fulfill its objective of providing clean energy, but the ultimate focus is to realize the maximum return potential of the plant. Here you can see I have pasted a picture, and here you can see what are the different different components need maintenance. So in the panels you can see that the panels needs to be clean. If there are any tracker gears, or if the panels are mounted on some trackers, then the trackers needs to be greased, the hydraulics needs to be checked, the controllers and the sensors should be calibrated so as to provide better information of how the generation is going on. The vegetation, snow and ice should be removed regularly, and it can sometimes happen that if you are just cleaning the panels by water or anything, there can be some marks, there can be some water residing at the bottom of the panels, which can again hamper the production and can also reduce to the degradation of the whole panel as well as of the whole string. The generation can be reduced. Other items you can see that inspection of SCAD system is important. The meteorological systems, you have to see whether the wires are not loosened. If the wires are loosened, it can lead to short circuiting also. So you have to test the inverters, that the inverters are performing good. I've seen a video where a person has stringed 22 panels. Usually other panels were stringed at 20. This increase in panels has led to voltage overloading, and that has caused some hamper to the inverter. A solar operation maintenance person goes there and see the situation, and then it corrects it. So while you are designing, you should also see that you are designing that the person who is installing the plant, who is designing, the person who is EPC of your solar plant is its best, performs its duty best, because then it can lead to increased cost of operation and maintenance. We can consider solar plant analogous to any individual solar business, like any business entity. While a solar plant has lower associated risks compared to traditional power plant, it is not completely risk-free. Just like businesses, the aim of PV plant owners should be to minimize production losses, significantly enhance efficiency, improve data transparency, improve profitability, and reduce the levelized cost of solar electricity, commonly known as LCOE, HOTO, is essential in the early stages. Even from financial perspective, any plant in the starting needs more care. After that, it needs regular preventive corrections and some other methods. Then it will perform good. The first 2 years, first year is very important to see that the plant is performing good and maintenance required is on the above scale. A misjudgment in output during the first year can affect the overall net present value (NPV) and internal rate of return over the 25 years. It can also be seen that the plant life can be reduced and the plant which is expected to survive for 25 years can only survive for 20 or 15 years only. It usually happens. So while installing, the panels must be choose correctly, the installation must be done correctly, the designing of the panels should be checked that there is no shadow as on over, and after that it must be seen that the person who we are giving the responsibility of maintenance is very professional and is available there at the time of the emergencies. Coming to the next slide, we will be discussing on the approaches that are usually taken by the professionals. Now, there are many approaches that are usually taken, but as of now, due to the limit of the time, we are only going to discuss the three approaches today. The first one is the corrective maintenance, the second one is the condition based maintenance, the third one is the predictive maintenance. Coming to the corrective maintenance, it is similar to the services done by a fire extinguisher. These activities restore the harm or exchange of failed components if any component has failed. Some corrective upkeeps like inverter resets or communication resets can be activated remotely. The different things that are included in the corrective maintenance are: the first one is the fault diagnosis, also known as troubleshooting. It involves identification of location and the type of error. With continuous monitoring systems, this step can be fast tracked. The second is the temporary repair, wherein we restore the functions of a component for a limited period of time. Then is the repairing. So in the repairing, we restore the damaged functions permanently. So first of all, it should be prevented that we don't need to change any of the system completely. But if it happens, then it's better to repair. It's better to restore the damaged function permanently. The corrective maintenance, as you can see, can strategically help solve a live problem on site. So operation can be continuously run smoothly and perfectly. Corrective measures becomes very important in big projects like utility based projects, wherein a small disturbance, a small shutdown can lead to devastation in cities or in areas, or can put pressure on the grid. The next is the preventive maintenance. As we have all listened and heard from from our earlyhood, in our childhood, we have listened that it is better to be safe than sorry. So, by keeping this in mind, the second approach that is usually taken by the professionals is the preventative maintenance. The preventative maintenance or preventive maintenance, most commonly known, refers to the routine and regular maintenance of assets in order to keep them running and prevent any costly underplanned downtime. As you can see that in the corrective maintenance, any changing any failed component can lead to another rise and can reduce the payback period and can increase the burden on the owner. So it's usually is usually suggested that preventive maintenance should be taken. It can be taken depending on what's the utility, what's the scale, how it is maintained, how it needed, how much maintenance is needed. But usually it is suggested by experts that at least once in a year, a solar plant of any size must undergo preventive maintenance so that any overburden can be avoided. The different operations that are involved in preventive maintenance involves a comprehensive test of all physical and electric components of an array, which includes the physical panel, that is the solar panel, racking setup, that is the structure, electrical connections and strings to see that they are performing as suggested and there are no loose connections, utility meter and the inverter. If any of these components yield issue or suggest faults, corrective maintenance will be applied. Now, coming to the third and the last approach that we are going to discuss today, this is the condition-based maintenance. This maintenance strategy monitors actual asset working condition to decide the type of maintenance it requires. In solar industry, this is accomplished through remote monitoring systems. So again, this is a little expensive, or a little bit expensive, but with more and more companies coming, providing an IT-based solution, one can see it. Some companies are performing it that you can see the real-time monitoring of how much energy is produced by the plant on your app, on your mobile apps. So it can be made economical in the coming years, but as of now, it's somewhat expensive. In this maintenance, the information is provided for battery, what's the battery voltage, what's the battery charging state, how much battery is charged if it's an off-grid system, what's the charge current, how much is the performance ratio coming of the plant, and module temperature. Now, module temperature is a very important parameter. Like any electronic system, the solar panels works in the optimum state at an optimal temperature of 30 to 35 degrees Celsius. Increase or decrease in the temperature can lead to the decrease in the overall generation of the whole solar panel. So daily data logs give insights about energy usage and consumption. These are the things that are generally provided by the ID-based softwares. A multi-control status screen can allow you to access data logs of multiple sites at once. So this is usually done at utility scale plants. It's not usually done on industrial as well as on residential projects. In industrial residential, it's usually the approach taken is preventive based, where before anything fails, anything bad happens, you change the component, you see if there's anything that can be changed, that can be overseen. Then we have corrective. Condition based maintenance is coming with the IT based solution. Many companies are providing it and are automating all of these things. Now, operation and maintenance is a very labor intensive task, and I will be speaking about this in a minute. So, a multi control system can allow users to access data logs of multiple sites at once. Therefore, control of every modular string lies in the hand of the remote users. So this is expensive, but it reduces downtime by 80%. Now, it's usually done by giving a digital twin, again, a concept that is in the working stages. And I hope that within 5 to 6 years, we will be seeing digital twins of the solar plant, which can generally and accurately tell us which of the components is going to fail after a particular interval. So, before a component fails, the digital twin can help us know that this is not working properly and can reduce the cost of the preventive maintenance also. So that's the future scope. Now coming to the automation part, how this system is getting automated. As I have already discussed, like many of the IT softwares are coming up, which is using AI technology, IoT, digital twin, and so forth and so on to make this labor intensive task easier, as well as it's very well known that data is the new oil. Now, I was listening to the meteorological department head. So, they are providing data, they are getting data from the solar plants, and they have to provide their weather prediction to the solar plants. So, especially, so what happens is that if it's expected by the weather department that tomorrow rain is going to happen, then the solar plants reduce their production. They do it like maximum solar panels are used, they divert the usage to somewhere else, or they store the excess energy before and only. They make this provision so that the grid doesn't affect. So usually data is also is being needed by the utility scale plant as of now, but the discussions are on with the solar plants of the residential buildings getting integrated with the grid, and so the data there can play an important role. So many IT based companies are using this data and are providing it to weather department as well as the state power corporations, so that they can decide where to take the electricity from, where to take the power from, how to distribute it. So data is the new oil. Again, different AI based decision data, different decisions are being used for doing the OMN activities. Now, To use this, different types of module cleaning are there. So if I reach to the next part, there are different ways in which these technologies is being harnessed. Let me see why it's not changing. Okay, yeah. So the first one is the robotic module cleaning. This is the first way and the most used way. Different startups are being revolving around it to see how a robot can be employed, especially in semi-arid areas and arid areas where the solar potential is high, but the labor cost and the labor availability is not so high, as well as the water is not there in surplus. So panels in the previous era, like in 5 to 10 years back, the panels were cleaned by using demineralized water with the improvement of manual labor. So manual labor was involved. So just to give you an example, a 3,600 megawatt plant in a hot region like Rajasthan would require almost a billion gallons of water in its lifetime. A billion, billion with a B of water in a lifetime. With utility scale solar plants coming more and more in the country, especially in the arid areas of Gujarat and Rajasthan, sourcing resources of such stinging qualities is becoming very difficult, as well as it is time consuming. And most of the cities in India are facing water crisis. So many of the plants, many of the utility scale plants to do the cleaning are providing solar robots. Now I want to ask a question, raise a question to all of the listeners over here, that can you tell me which is the perfect time to clean the panels? Is it in the morning, evening, or in the afternoon? Can just any one of you comment down here and let me know that whether any of you know the answer of it? Evening. Yes. So yes. So usually it's done in the evening or in the morning if it's in some instances. If in the night there are some dust storms on there. So yes, Mr. K Ravi, it's usually preferred in the evening. So it's because it's done in the evening, because in the afternoon the production is high. The plant is producing the power, and the solar panels, the robots can disturb it, and it can cause some disruptions in the solar panel and in the string also. So it can lead to some degradation also. So it's usually done in the evening, when the after the sunset, or in the morning before the sunrise. So that's very good answer. That's very knowledgeable one, Mr. K Ravi. Congrats to you. So many of these panels are used. These panels are using vacuum cleaning or are just blowing the dust. They are not using any water, so no watermarks are there. And these surfaces, by sweeping, blowing, and vacuuming, removes dust very effectively. Like if I just have to give you a figure, I was reading a paper and it can remove dust with 90% efficiency and reducing the water consumption overall. If it's sometimes needed to wash it with water, but it's reducing the water consumption by 80%. So that's the impact of the using robotic uh, for module cleaning. The second method is the thermographic imaging. Now, traditionally, thermographic inspection of panels involve technicals walking around the parameter and scanning panels and strings at an angle. So, any human error can take place. It can happen that a person is not seeing properly. It can happen that one or two of the strings just got out of his sight or out of his eyes, and he's not able to see any difficulties. Now, this process, as you can see, is involving human intervention, is not the best, as it cannot detect all the anomalies. Moreover, it is limited by the amount of navigable space and also on how skilled the labor is. The amalgamation of unarmed aerial vehicle, the UAVs, the drones, helps visually inspect, or infrared thermography or electroluminescence offers a promising solution to this problem, where a UAV drone, as you can see in the image, will be flying above. It can get a bird's view and it can see for any sub array, any table, that how it's producing, and from it it can know that is there anything that needs to be done, any string which is loose in. The third one is the real-time monitoring. Now, instead of relying on your annual inspection, wouldn't it be better if you were to able faults or failures in your system in real time? So that's what I'm saying about the automation. So by the help of the IoT sensors and cloud-based data analyzers, it is possible to real-time track how is the production happening. Is there any defect coming? The SCADA system is usually employed at the utility-based scales, and performance forecasting, root cause analysis, daily power prediction is usually done by the SCADA technologies. Now, these technologies overall, the robotic system, the thermographic system, maintenance drones, the SCADA system, all allows users to pinpoint defects at the initial level, at inverter level or string level or module level, and can help effectively see that how the generation is going to take place. If I talk about the future scope, the global research and analytic firms like Wood Mackenzie has predicted that the global non-residential market for solar O&M might reach 9.4 billion US dollar, billion with a B, billion US dollar by the year of 2025. We are in the year of 2021. In India today, we are having utility scale power plants of 30-35 megawatt that are running and are being operational, and more are coming. The target of the Indian government, Indian central government, is to reach 100 gigawatt by the year of 2025. So you can see that in India only, the operation and maintenance business is going to prosper. Different new technologies are going to come to effectively, with low labor, low costage, we can visualize how the production is going on. Now, almost 5% of the global PV market is nearing the inverter end of life. In the global market, the solar installation started way earlier in the year of 2005 and 2010, and in the year by the end of year 2025, most of them will be needing reinstallations or refabrication or some type of maintenance. In India, we reached a boom, a solar boom in the year of 2016-17, and it's possible that in the year by the end of year 2030 and 2031, because of the increasing asset management and the rising focus also of the government on management, it can happen that this O&M business of India can also become 10 to 15% in the solar industry. So there is a huge potential that is untapped. Many players are in this line. They are fighting, but the piece is big and is enough for everyone. Now this number for India for all over world is expected to grow by 16% by 2025, as I have pointed out. Now of this total, the Asia Pacific region accounts for 4.1 billion US dollars. The Europe and the Middle East account for 3.5 billion, and the America account for only 1.8 billion dollars. So I'm seeing this data. So there's a question from Mr. Lalit Rawat. What is the solar installed capacity in India right now, including rooftop? So actually, Mr. Lalit, it's very no one knows that how much rooftop is installed, especially in residential purposes, and more and more the focus of the government is to make utility scale plants. So as of now, with a recent report that has come from the Ministry of Power that I have seen, it's estimated that 36 gigawatt installed power installed is there, including rooftop, ground mounted, and floating. All of them included in India as of now. Many of them is coming. So I think so that is this satisfies you. I will be seeing this data once more, and will try to pinpoint it how much is the rooftop. So one more thing is there that I would like to share with all of you over here, that in India, like in the Indian market usually follows the American market in all aspects, but we can see that in the American market, the utility scale plants are not there. But more and more people are encouraged, and more and more people on their roofs are on in their home are installing rooftop solar plant. Thanks to Tesla and thanks to electric vehicle technology that is coming there, many of them are using electric vehicles. So because of that, they are more inclined towards rooftop installations. So usually it's predicted, it's estimated that in India also, once the EV system is installed, once the EV ecosystem comes into play, more and more people would be would be inclined towards this installing rooftop solar plants over their rooftops. So we can see that in the 10 to 15 years, a major chunk of rooftop solar plants can increase, which will make increase in the preventive approach of the maintenance. So I think we will be able to see this soon in the coming months or years. But as of now, solar rooftop adoption in India is very poor. Ground mount projects are there, floating projects are coming at a very high pace, but that's why we are working to increase the solar rooftop adoption in India mainly. Now, coming back to the topic, aging solar plants, as I have already told you, are an opportunity for repowering activities, while new projects can take advantage of advanced analytics. Now, this is said by Daniel Liu of the Wood Mackenzie Principal Analyst. Daniel Liu, who is the principal analyst in Wood Mackenzie. That's a reputable firm. Other significant factors which impacts O&M business lies in the cost and the contracts that developers and asset owner managers are doing. Asset owners are more likely to incur more cost with a la carte service structure than if they offer all in service contract. So I will. It's nothing to come like many of the, especially in the residential projects, many of the installers I am seeing, I am interacting with some of them, are preferring that the one who is installing on a plant, that the one who is installing the solar plant on a roof or on the any of our ground, any of these, that same person do the maintenance also, because we have some confidence in him. And this is an opportunity for the EPC players, that now with the EPC market coming to a saturation, they can shift their horizons to the maintenance also. And with the maintenance, they can do the asset management and can improve their margin, and can also improve their cost, as well as it will be beneficial to the customer also, because then it will not be shifting the responsibilities that design is bad or anything is done wrong by the installers, and will give more and more transparency also in the name. So this is a welcome move for all EPC players to see and move to the O&M also. So by excluding vegetation management, corrective maintenance, and module washing, it is seen that 40 to 45% of the cost in O&M is because of these three activities. And usually the contracts miss out on all these things, like they don't do module washing, they don't do corrective maintenance properly, and they don't exclude the vegetation, especially in the ground mounted projects. So if you are an EPC player and you're looking to expand your horizons, it will be very good that if you're going for the operation and maintenance. Now I would like to show you one more thing. So we as in the solar labs, we have made this software, we have developed this software which helps to know that how the shadow is going to fall. Now what usually happens is that if a plant is designed in such a way that let me show you. So on today's date of 2nd of September, if I scroll this bar a little bit on my right side, so here you can see that at around 1:38 p.m. you can see that some shadow is coming, half of the panel, about half of the panel, and here a little amount of quarter of the panel is covered with the shadow. Now what this will do is that this part of the panel will not be producing any power. Here there is no sun coming, no sun radiance coming, whereas in the rest of the solar panel, as you can see here, the radiance is coming, Now it's because 130, so the irradiance power is good, and this thing can lead to the degradation as well as the reduced what should I say, reduced generation for the whole string. So suppose that all these 7 8 panels are string together in a single string. So what will happen that because of this shade, only a half of the shade, this solar panel will not be performing to its optimum level, and this can lead to the hampered generation of all these 7 to 8 solar panels, which will always reduce the production, increase the profit margin, increase the payback period, and reduce the savings. Now, all these things, if acceptable to one, it can also lead to that because of this shadow. What can happen, there can be some thermal effects also. Now this area will be highly heated. It can reach to a temperature of 40 45 degrees Celsius, whereas this area could reach to a temperature of 35 degrees Celsius, which can lead to some thermal what should I say, some thermal inadequacies, and this can lead to the total damage of this panel. Now it can happen that fire can take place. It can happen that only this panel is impacted, nothing happens. The whole generation of this panel reduces. It can happen the whole of the sub array gets destroyed. So anything can happen. Therefore, designing is a very good thing, is a very important thing, and it should be done very by keeping everything in mind. So this is at 1:38 p.m. This is of 2nd September. So now if I move it somewhat later, so here you will be seeing on 22nd of March at 1:32. So these panels should not be coming. These two panels should not come at any time, and these two panels should also be moved at the front row. So what can happen if a person is a good designer? All these 4 panels will be moved to this row, and here only 3 to 4 panels should be placed. So that would be a good design, but this is an example of the bad design. So in this way, our software is helping the designer people to get involved in the operation maintenance, to get a taste of how operation maintenance is taking place, how they are designing, how placing the panels can impact the whole of their clients, and one client can give you many clients, and one client can lose you many clients. So here we are using this as a method to show that how it's taking place. Now suppose if there is any tree over there, and you want to see that if any shadow of the tree is taking place, you can move the tree, and so you can decide that how the panel placement should be done. So now if I move to the 3D again, move here and do the sun simulation. So all these panels should be taken away. Now you must be wondering that I am not saying anything that the shadow is coming at 4 p.m. or 3 p.m. because the sun irradiance becomes very low and it doesn't hamper that much. It usually is very critical time is 11:30 to 1:30 2:30 p.m. is a critical time depending on the location, the geolocation, and the site, as well as the different shading, how the shading is coming. So this is how our software is helping the EPC players to get a taste of the maintenance. So is there any question as of now? Feel free to ask any questions regarding operation maintenance, regarding the software, regarding solar design, and also give us some idea, give us some topic for the next week that we should come and give a brief introduction or give an introductory lesson. We will also try that operation maintenance, we can give a more elaborate view on operation maintenance in the coming lessons. So bear with us. Today we have given just an introduction of how things are going place, what's the future, how EPC players can get involved in it, and what actually is asset management. So there's a question from Lalit Rawat. In this project, how a bypass diode is installed per string or per module, or reduced shading losses. So as of now, this software doesn't give you this string or doesn't provide string. So in here we doesn't have installed a bypass diode, but yeah, it can happen that Usually per string bypass diode should be installed. That will be more economical and feasible. So per string, I think would be preferred in my view. Any other question or any other doubt that is coming in mind, or you can suggest us any other topic for the next week that we should come for the master class. So there's a question from Mr. Lalit Rawat. How can we reduce misconcern regarding rooftop in domestic areas? So that's a very good question, Mr. Lalit. So usually in India, we are very price concerned. It happens to all of us. So we can do this by government has to intervene somewhat, and then like I have talked to many of the people. So one concern that they have is like their roof will be somewhat destroyed. There will be some leakages. It can develop some cracks, or it will be too costly for them. It will be a too costly an affair for them, and maintenance is difficult. So it is usually taken in the mind of a residential person in while he is installing or she is installing a rooftop plant. So by what we can do is we can show them different webinars. That's why we are conducting different webinars and different master classes to make the general people aware that rooftop installation is the future, solar is the future, and by solar one can reduce the cost, not only just the bills that they are paying. The We are seeing that in a couple of years the state discoms will be privatized. There is some transmission losses, and so the tariff hike is inevitable. So by in my opinion, if we can show them that there is nothing to worry about, their roof will be good, nothing will happen to the good to the roof, and by keeping that only in mind, we have used 3D modeling. So it to show so as to visualize the rooftop person that this is how your roof will be looking like. You will be getting ample space for walking. There is nothing to worry about that there will be some cracks formation, that it is a tedious task. Nothing is getting involved, and I think so with time their misconcerns will be reduced. And I hope that with lower and lower lithium battery cost, we can move to storage on off-grid plants sooner, because in on-grid the government is somewhat discouraging the on-grid solar plants but is encouraging the off-grid solar plants. So I hope that people will understand it and will move to the off-grid solar plants soon. Thank you, Mr. Lalit, to come into the masterclass and asking questions. You really make this session a dialogue rather than a monologue. So thank you to you, and thank you all other people to come on the masterclass. I hope that you can contact me on my mail ID, that is ayush@thesolarlabs.com. And if you have any questions, any of your doubts that you are having, we can come and discuss and can increase our knowledge together. Also, if you want to know anything more about the software, anything else, feel free to contact me. Also, you can give me any other suggestions of yours on topics that we should take in the next